Hello everyone, so we are ready to start. Thank you for being with us. My name is Satyam, you can call me Sam, and today we will be doing like a gentle introduction to machine learning and data science in general. We will be writing some code in the end, and we'll just be writing a simple Perceptron algorithm. Don't worry about it, we go through all the steps. So I'm sure you all know that we are an AI club, and we often tasked with this problem with people confused about what is AI and where does deep learning fit in it and machine learning kind of goes in it. And in a nutshell, AI is anything that makes a computer act more like a human being. Right now, it doesn't have to be machine learning. It doesn't have to be deep learning. For those of you who were here with us last week, we did a chess AI, and it involved nothing. It involved no machine learning, no deep learning. It was just a simple search algorithm, but it allowed a computer to play chess. So that's considered AI. We'll be here today in machine learning. We will not be going over deep learning today. We'll be machine learning. Deep learning is just a subset of machine learning, and machine learning is just more broader. And we'll be just covering the basics and until we get to the coding part. Right. So there's two essentially. Machine learning is you can categorize into two parts. The first one is supervised machine learning. Supervised means that let's start with so machine learning. What it really is, it takes a set of data and it learns the underlying patterns in that data to predict a class. So for example, data would be picture and class would be, is this a picture of a cat or a dog? This is supervised because you already know the label. We know that we learned that it's a dog, it's a cat. In data science, this has a lot of applications like your spam folder. When was the last time any of you got a really bad spam email? Right? When was the last time you actually saw a really bad garbage spam email? That doesn't happen because using data science, your email, if you use Gmail, anything else, it already filter that out using machine learning. Right? If you can give it a text of an email, the algorithm can figure out if it's a spam or not, and you don't see it if that happens. So that's supervised learning. So there's two. So in supervised learning, there's two kinds of problems. There's classification, which is non-numeric. So classification, dog and cat it's not a numeric label. It's dog or cat, be spam or not spam, fraud, or regular transaction. That's non-numeric. And then we have regression, which is numeric. Regression could be predicting the price of a house. That's a number. So that'll be the second part. And this is just an example. One data science problem using machine learning would be, let's say you run a company and you have all this information about your employees. You have their score and loss evaluation, your satisfaction rate, time and credit roll, and you want to build a model to predict if that employee is at risk of leaving or not. So again, this is a classification, leave or not. And then the point is, once you train the algorithm on some data, let's say you have a new employee or a bunch of employees who don't know if they're leaving or not, you want to intervene or not, you give the model their data, and with some accuracy, the model can predict if they're going to leave or not. That's one problem you can use data science for. So the other side of this is the unsupervised machine learning, where you don't have the class, there's no cat or dog. It's just, you have some data and you just want to cluster them or group them meaningfully. You don't know what they are, it doesn't matter what you call the groups, you just want to put similar things in one bin. So one way you do that is you do something called clustering, and where let's say you have a business and you want to group your customers because you want to give specific attention to similar customers, and there's no label for customers, just the customer, you know their habits maybe, and what they buy, when they buy, and you just want to group them together. There's no label, but you want an algorithm to learn the underlying patterns and group them together, the similar customers together. It's also used in something called market basket analysis, which is the way Amazon does. When you buy something on Amazon, you can look at something and they give you these items are frequently bought together. That's an unsupervised machine learning. The algorithm knows that if you look at this thing, it knows that people who look at this thing also look at other things and will buy it. They recommend it to you. That's another use of it. And then there's the dimensionality reduction. I'm not going to go this little map is just saying that. So a lot of dimensions can be good and bad in data, and dimension just means features, which is basically, let's say, so going back to the example for the employee, each of these, the score and last evaluation, satisfaction rate, all this information is a feature. It's a dimension. So there's something called cursive dimensionality, which means that after a certain while, if you have more and more features, your model will do poor. It won't be a good thing for the model after a while. So what you want to do, what unsupervised machine learning can help you do, is take a lot, let's say 100 bits of 100 different information about an observation, and then you can kind of squeeze it into 10, the 10 best ones. That's also another unsupervised machine learning method. There's another use of it. right? And these are some of the really popular supervised machine learning algorithms you will come across if you've done anything, and I listed them in the order of complexity. So linear regression, that's just regression, like it takes a bunch of inputs and gives out a numeric output. And your logistic regression, as you go down there, it gets more and more complicated. The last four are something called ensemble methods. Like I won't go into this right now because that's what we have next quarter for. And so these are just like names of like some really popular machine learning algorithms that you might have seen. Right. So how does the machine learning algorithm actually learn? So in a nutshell, you can think about it is really two different ways an algorithm learns. So one, it can try to learn a bunch of rules about the data. So this is a set of rules, right? Let's say you start from the top, and let's say there's an animal, and you don't know what that animal is, but you just know all this information about it, right? So I don't know what the animal is right now. The label, I don't know. It's a question mark, right? So I'm going to ask myself, does it have more than 5 legs? If the answer to that is yes, I'm going to go down here, right? Is it hiding under your bed? If the answer to that is yes, I'm going to go down here again. And then is it the Star of Charlotte's Web? No, then the answer is bed bug. So these are the rules. I'm going to follow these rules. I have all this information, but I don't know what it is. So I'm going to follow these rules till I get to a class, a label. So this is how a decision tree works. These are a set of rules for the data. Similarly, we have another algorithm that learns from the rules. This is the knife-based algorithm. This is the one that you usually use for text classification, spam and not spam. It's the same thing. It just learns a set of rules. If you'll probably take some statistics class at UCI and you'll do the Bayes rule, and the second way there's another way a machine learning algorithm might learn is by fitting a line to the data. It's separating the data it's with a line. So one example of that would be support vector machines. You have these two classes. You have the blue class and you have the red class, and these are the features. You know one thing about it, you know another thing about it, and like graphically you try to fit a line between them. So next time, let's say you don't know, I have a dot, I don't know if it's red or blue. I'm going to apply it over here. If I end up applying over here, I'm going to say it's the blue class. If I apply it over here, I'm going to say it's the red class. That's another way. Same. This is support vector classifier. A good thing about this particular algorithm is it just doesn't focus on fitting a line, but it also this is something called the margin. It also focuses on maximizing this margin because you might have a point that's really close to here, so you want to keep all the points as far away as possible from this margin. And so another would be logistic regression. This is also classification. The same thing. It tries to fit a boundary. Anything over here is red. Anything blue is separate into two classes. All right. All right. So today, what we're going to be doing is we're going to be coding a perceptron. So this is a linear model. So the way it makes predictions is, so it's just an equation for a line. It has something called weights. Let's say you have two attributes. Let's say I know x1 about something and x2 about something, right? And what I'm trying to teach the model is something, the weights. How much weight am I going to assign to each variable in order to make a prediction? And so what it does, let's say I have, like, right. So the way it learns is, so the way the perceptron algorithm runs is that we start with completely random weights. Like we start with completely random weights, and the way it learns is like, given a set of data, it's going to start with these random weights. It's going to form a really random equation. Let's say 3x plus 2y is equal to something, right? And according to that, it's going to use something called a step function. So let's say the step function is really simple. So whatever value the function outputs, it could be any value. If that value is less than 0, it's going to say it's 0. If that value is anything from 0 to infinity, it's going to say it's 1. That's all it does. The reason for this is because it's a classification problem. The value can only be 2, 0 or 1, which is yes or no, cat or dog. Right? So, we just call it 0 or 1. It could be anything. So the reason for that is because our output can only be yes or no, or 0 or 1. That's why I use the step function. If this was a regression problem, we would just stop here. We would just have an equation. It would give us like 55. That's $55. That's it. But because we need classification, we need to only have 0 and 1. For that, we just put another part on it, and we say, okay, so if the function outputs something less than 0, we're going to say it's class 1. If the function outputs anything above that, we're going to say it's class 2. Okay, so how does it learn? So the way an algorithm learns is like we start with completely random weights. It could be anything. I mean, when we code it, I just used like a random model. I just generated two random numbers between 0 and 1. And then what it does is it takes those weights and it will just classify each point in the data set with those weights, right? And once it does that, it's going to go to each point, right? So let's say we start with this really random line, right? We haven't done any machine learning yet. We just start with this random line, and we put it on, and then we see that you have blue points and red points. This is where the blue points is supposed to be. This is where the red points is supposed to be. And we see this line, like somehow it just randomly classified 2 points correctly over here. It misclassified 1 red point, and over here, and it misclassified 1 blue point. So the algorithm will look at every point that is classified, and then it's gonna look at each point and see, okay, how far are you from the line? Because I want to move that line how far you are. So then it's gonna it's gonna ask each point over here. Let's say the first point that comes up is this misclassified point, and the line just moves down here. So it'll move the line over here. So now we have 1 misclassified point. So the next step, when it goes to the next classified point, it's going to ask it, okay, so it's going to see that this is not classified correctly, so it's going to move the line again until we get all the points in here. The important thing to remember about that is that you cannot give any of the points a lot of weight, how you move the line, because the point of this algorithm is to basically learn the general pattern. You don't want to model it too closely to that data. You just want to learn the underlying general patterns of the data, because at any given point, it's impossible to have all the data at one time present with you. You can't have that. So you have a set of data that belongs to some other bigger part of data, and you're trying to learn the general patterns in it. So for that, what we use is something called a learning rate, which is basically another rate. What we do is, when I'm moving this point closer to this point, I'm not just gonna move it completely. So I'm gonna take how far it is. Let's say the coordinate is it's just 5 points further than the line. I'm gonna multiply that by 0.1. So I'm only going to move it 0.5 times closer to that. Because if I don't do that, I'm going to end up giving all the points a lot of weight, and it's just going to go crazy. So kind of like show that to you in practice. We are going to be coding a perceptron algorithm. So the first thing I need you to do is type this into your computer. This is a link to a Google Doc where I have the data set that we will be using.
Pull up the link again so we can
my bad. Sorry about that, guys. I just need you guys to save that to your computer. Just remember where you saved it, because we will be uploading it again very quickly. Who needs more time? So we're done? Does we need more time? Okay. So next thing, just open up another tab and just go on over here, colab.research.google.com. So we're using something called Google Colab. It's just built on top of Jupyter Notebooks. You don't need to set anything up. Once you do that, you'll be able to just directly write Python code there. So once you do that, it should look something like this. And then you just go to File, and then just New Python to a notebook. This should bring you to something that looks like this. So if anyone is having any trouble, we have some really great mentors right over here, and they will be more than happy to assist you. So if you have any questions, just like raise your hands right now.
Thanks.
So is everybody here already? Is there someone who is not here? You okay? Everybody who already has this, can you put your hands up, please? Everybody who already has this? Already there?
Yeah, you do Python 3, right? Python 3?
Python, yeah. Okay, you can put your hands down. Okay, so I'm going to go ahead with this. And yeah, we're going to code a perceptron from the very start. And first things first, just click on this left arrow over here. And then I need you to go to Files. And you will just see the sample data. You won't see a data.txt because they haven't uploaded yet. And then I just need you to click upload and go wherever you just saved the data set I had you guys save and upload it. And then you should see it like that. And we can't move forward before you do that. So everybody get it? Just say data.txt, whatever it says is important because you will be reading from it. So if you have it saved under a different name, just make sure you can see it because you're gonna have to change it in your Python files. Okay. Okay, everybody good? Moving on. All right, so the first thing we're gonna do is we're just gonna use two libraries. Like we're gonna use NumPy. We're just gonna import it real quick. And we're going to use pandas to read the data. We're only going to use the pandas library to read the data in later on once we're done writing in class. So to run a cell, you can either click this little button over here, or you can just press Shift and enter at the same one after the other, and it'll run the thing. So if I do this, it'll run. Or you can just press the one if you haven't used that before. Right. So this is the first thing we do. We just imported NumPy. This is just a data structure. It's nothing else. It's a list, but it supports vector computation. That's it. You don't need to know much about it. And we're going to start by writing the class for our very first machine learning algorithm. Right. So we're going to just write a class called Perceptron. All right. So I'm going to go in the order where I talked about. The first thing we need is a step function. Step function is just something that takes in a number, and if the number is less than 0, it will output 0. If it's not less than 0, it will just output 1. That's all it does. So we're just gonna put that in here. Statement. Alright, so we got our first little function ready to go. The next thing, we need another method, which is our prediction method.
Sam?
Yeah.
Can you increase the zoom a little bit?
Better?
Is that okay for everybody?
At sign. There's a at sign.
Thanks, buddy.
Okay.
What is that? Oh, it's a decorator.
So we get our next method. So this was a prediction method, and so like I said, I talked about it. This is just a function. So our prediction method is doing nothing. It has, let's say, the equation 3x plus 2y. You're going to give it x and y, and it's going to compute that. That's all it's going to do. It's nothing complicated. That's what we're going to do. So x would be our data, our x and y, what we're going to plug in. It's just you write it in statistics. You just call it x, your data, and you have w, which is the weights, like whatever our function is, and then we have b. All right. So I forgot to talk about this because since this is a line, you do need an intercept. So this is mx plus b, like the most basic math function of a line. So it needs to be, it's just an intercept. It's in machine learning, it's usually referred to as bias. So that's why it's called b.
So you can do it. Yeah.
So what we can do here is, right, so we're going to call our step function because we are passing whatever the function gives. Are you going to see? Is that better? Okay. So yeah, so like I said, whatever this function outputs, we need to pass it to a step function, which will be a number, and it'll give it out 0 and 1. So we're just going to call a step function. And what we can do is, I'm just going to use I'm not going to write it out how to compute it. I'm just going to call a function that already exists in NumPy module. It does nothing but multiplies those two our weights in the class. You don't need to worry about it. I'm just calling a built-in function to multiply those two things together. Jason. Can you transfer that? First, we're going to give it the data, and then we're going to give it the weights. That's funny. 6:32 an hour. It's cool. And then we're going to add the bias to it. That's just basically like an equation for a line. It's nothing else. We have our data, and we have the weights, and we're going to add the bias to it, and we're going to pass it all to the step function, which will return either 1 or 0. Our prediction can only, like I said, we only have 2 labels. So when we predict something, it has to be 0 and 1, and that's all we're ensuring here. We're doing nothing. It's not complicated. And if you're looking at it wondering what the hell that means, it's nothing. It's just I'm just calling a function that will plug in the values of a function and give me an output. Like, I don't want to go ahead and code that myself. That's all I'm doing. So okay, so now we're gonna write our perceptron algorithm, the one I talked about, the one where which will move the line up and down depending on where all the points are. The one I talked about. So this is a really important function in this class. So we're just going to call it the perceptron algorithm. So x is okay. So we're trying. So y is the label, and x is, like I said, x is the data. X is everything we know about it, and y is what we're trying to predict. So that's how it goes. So x is like label 1 and 2, and y is the label 0 and 1. So again, since this is a supervised machine learning algorithm, when we're training it, we have to know what the label for each observation is. We cannot train the model if you don't already know that, because it's a supervised machine learning technique. So when we pass values to this algorithm to train, we're going to need the attributes of the data, what we know about it. Y is what the label is, and then we're going to get the weights and the bias. And I talked about the learning rate, which is how much I want each point. So the learning rate is just a way of saying how much I want each point to contribute to how my function looks like. This should usually be low. It should never be as much. It should never be 1, right? Because that will just make your algorithm go haywire. It's always like a percent of it. So right now I'm going to use 0.01. That's just 1%. I want each data point to contribute only 1% to the function. That's in a very rough and way I'm saying that. So that's the learning rate. Right, so let's write this function out. Right. So this just means like I in range then of x. We're just going through every point I can. Every point in the data set, that's all it means. And then
Can you scroll up?
yeah. Is that better? Oh, my bad.
Yeah.
Is that good?
Yeah, that's good.
So, right. So y hat is statistics like y hat. It just means the label, the one we already have. So y hat is just a label. Like this, in statistics, that's just nomenclature. There's no meaning behind it. It's just called y hat. We already have, and then that is so. Like I said. So you're gonna call the prediction function over here. All right, so this is where I check each data point. Right, so this is where I'm checking each data point. So I'm saying that. So now we're going to write when we check each data point if it's misclassified or not classified, correctly classified, and if it's misclassified, was it 1 and was it classified 0, or was it 0 and it was classified 1? That matters where you move the line up or down. Right, so let's say like. If your point that should be like if the point is below the line but it should be up the point, you're gonna need to move the line down. If you have a point that should be below the line but it's above the line, you're gonna have to move the line up. So it matters like which class it ended up in. This is just all I'm doing with you. So we need to change the weights, and we also need to change the intercept. If we let the intercept to stay the same, it's just going to mess with our prediction there.
Does it matter that in the parameters the W is lowercase and then everyone else is uppercase?
No, if you so, okay, so yeah, I did make a mistake here. So this has to be uppercase, but yeah, it was fine. Right. That's the same. Thank you for that.
Yeah.
That was giving me an error.
Also, the learning rate, the R is capitalized on the last one.
The last one.
Oh, sorry, yes. No worries.
Yeah, just let me know because like, thank you, appreciate that. So this is all this function is doing. It's going to go through every point. It's going to see if the point is not misclassified. It's just going to leave the point as it is. It's not going to change the function for the points that are correctly classified. It's only going to look at the points that are misclassified, and depending on where they are, it's either going to subtract the weight from the total weight, or it's going to add the weight, depending on do you want the line to go down or do you want the line to go up. So all this function is doing. Multiplied by, of course, like I said, the learning rate multiplied by the learning rate. How much do we want each point to contribute to the function? So this is all, and after it's done, it's going to return the updated weights. We start with a random weight, we go through each point, update the weights and the bias, and then once we're done going through it, it's just going to return it, because we're going to use that. So these are all our class methods. Now we're going to, so we're writing the model as a class, because we're going to initialize an object of that class. So you just have to write the dumb data methods. So when we initialize the model, we just need to give it two things. We just need to give it the learning, what the learning rate is, and a random seed. So the reason we do a random seed is because we will be generating random weights to begin with, and this just makes like let's say, because it's a random number, if you don't set a seed, the next time you start your model again, it might start from a different number, giving you different like predictions, which has nothing to do with how the model learned, but because of the random seed. So you want to make sure it's reproducible next time you do it. So just set the seed. You say this is the random number my model is going to start from, like the random seed. That's all we do. You can set that. If you don't even set it, like that's why it's like a default parameter. So we're just gonna create the. So I'm just calling my learning rate alpha just because it's called that. Usually that's how it's called in stats. You can call it whatever you want, doesn't matter here. You can leave it be your learning rate. So we have our algorithm, we written the code to initialize it. Now we're writing the fit method. So the reason why I'm writing this class like this is if you use any libraries like scikit-learn, like this is how all the models are, like how the class is written. You have you initialize the model first, and then you call fit on it. This is where you get the data the model wants to learn. So that's the only reason I'm modeling it like that. I'm sure if you you can probably write this class in a different way and make it do the same thing. That's the only reason. So now we're going to write the fit method, which is going to take the data, the attributes and the label, and it's going to run the algorithm to learn on it. Right, Right, so I think I forgot to go epochs, but the algorithm we just talked about, going through every data point once, that's considered one epoch. But usually you do that step multiple times. Just doing that once, because like I said, we only have each point contribute 1% for 1 1. So we usually do that many, many times. So our accuracy like starts decreasing. For a while, it will usually go up, and then after some while, it will start going down. So just doing that algorithm once is called one epoch. The default parameters we do it 30 times. So, this is where I just generate, to begin with, I just generate random weights.
It's too.
And so that's what we're doing for every, let's say for every epoch, every time we're just gonna update the weight with the algorithm. That's all this while loop does. So I'm just going to write a print statement. So like every epoch, we can see how the weights have changed. It doesn't nothing for the functionality or like the algorithm. It's just that I want to see how the weights are changing every time. So I'm just going to write a print statement. Once we go through all the epochs, we can just update the weights that we initialized in the beginning, because we've gone through the algorithm as many times as the user has told us to. So we're just gonna, once we out of the while loop, that means we've gone through it as many times as we are told, the function was told to. We're just gonna update the weights after that. So you ready with me? Good. Yeah.
I think you have an extra underscore between random and C. I think you scroll up a little bit. Yeah, the second line of your function.
Over here.
Yeah, and then there's another underscore, I think self dot underscore of perception in the while loop.
Over here.
Yeah, the perceptron, it should just be one underscore.
Yeah. Okay. Thank you. So is everybody with me? All good? Are we here? Okay, so now we're gonna write the predict method, which we'll just take. So this is the method we actually just give like attributes without the label. Because now after we're done training the model, like I said, we have to give it data that it hasn't seen before, or data without a label, and the point is to predict it. So this is the function that will just take just the attributes, and then it will take the weights that I already learned and compute the function and give us the value of what it thinks the model thinks it is. We're just gonna write a simple predict function. So we are done writing our class. You can go ahead and run this whole cell. Just go ahead and just go over here, run it. So now we're in the whole class of perception algorithm, and now what we're going to do is, so we're going to use the data set that we just uploaded to your Google Colab notebook. We're going to read that in using pandas. It's really simple. It's just one line of code.
Sam, can we just show how to upload the data again? I know a few people in the back missed.
Oh yeah. So it's just here. So you just open so there's an arrow over here. Just use that arrow. And you go to files. There's an easy way to do it. I'm not sure how to do it in Windows, but if you're on Mac, you can just right-click that, and then there's a copy file path option. You just do that, so you don't have to type out the file path. So does everybody have the data already uploaded to the Google Colab notebook? Is there anybody who doesn't have the data? They can't see the data over here. Okay, so I mean, yeah, you can just once you have the data over here, I would just suggest right-click it and just copy path. So you have the path copied to the clipboard because you're going to be writing it. And then whatever path you have, you just give it there should be a data.txt. And then we say header is none. So what this means is we don't have the labels for these columns. These columns, usually when you have a data set, it'll have a label, what does it signify, right? So like if you're looking at foods, it could attribute could be color. So we'll say that this is the color of the food. So the RDS doesn't have any labels. It's just a bunch of numbers because I just want to kind of show you like given any attribute, like just numbers, like how it can learn. So that's why we're just going to say header is none because we don't have the name of the labels, name of the attributes. And so this data has 3 columns. It has the attributes and the label. We need to separate it. We need to because the data and the label has to be separated in order to pass it to the algorithm. This we're going to do. So we will go over pandas, the library pandas, like extensively over the next quarter. So if you don't understand, like just line code or these functions, don't worry about it. All we're doing is for this line, I'm just extracting the first 2 columns of data, which are the attributes. That's all I'm doing. So everybody here? Okay, so now we're gonna initialize the model from the class we just wrote. So yeah, learning weight, like we said, when we initialize it, we just need to give it the learning weight and a random seed, so we're going to give it that. Even if you don't, we already have that as default parameter. You can tell it the learning weight should be 0.01. Random seed, I'm going to set 42. You can set it whatever you want. You might not get the same rate initialization as me. So once I'm done that, once I'm initialized my model, then I'm going to fit it. Now I'm going to call the method we wrote. I'm going to call fit on it. X and Y, we just have our X and Y, we just took them out. And then I'm gonna give it just 30 epochs. I'm gonna say like run the algorithm 30 times on the data.
I have a question.
So,
Hey Sam, I think you had a question?
yeah.
So at the beginning of Perceptron, it was like learning rate and random speed were almost like constants that you set for those two.
I can't really hear you. Can you speak up? Sorry, my hearing isn't like 100%.
No, like when you created the class Perceptron,
Yeah.
when you made the parameters for constructor,
Yeah.
it was as if like you made constants. So why are you writing them again like the same constants?
Oh, just to show you, it doesn't matter. I'm just writing it. I don't have to, right? But if I had to change it, if I wanted different parameters, right now, like my default, when I made the constructor, I set the default to 0.01.
Oh, those are
Right, I always said so what that basically means is like if I don't input anything, I want it to be that, right?
Okay.
But if I want to change it, over here I haven't changed it. I just don't want to leave it empty for you guys, right?
Right.
If I want to change it, I'm gonna have to like put it in. Okay, so yeah, so is everybody here because I'm gonna run it and I'm gonna cross my fingers and hope there's no more errors because it's not gonna run. All right, is everybody here? All right, moment of truth, guys. Oh wait, what? All right, so you're gonna see this huge output. So I'm gonna try to explain this to you guys, okay? So this is it. So you see over here the first 2 weights. This is what the random weight was initialization. Like this should be the same because we had the same random seed. So this is what the model. This is where we started. We had a random number, and as each epoch went through, you will see the numbers change in direction of where the line is going, up or down, depending on how well it can fit all the data points. Right. So if you're gonna scroll down, you're gonna see that both the weights actually just went negative. That doesn't mean much. Just that's how the function is fitting the line, right? So you go through each epoch and you're going to see that in the beginning it was like a huge increase and it just goes down 21, 15, and then as you go down, it's going to slow down because like after certain epochs, the data is the model is relatively well fitted, and it's just like nitpicking at that point, slowly coming down, right? So this is the output. You see like all the weights started and then all the way down, and these are your final weights. This is what your model learned. This is the function. You can think of this as negative 0.71x. Plus minus negative 0.20y plus 0.43. This is the function that your model learned, and I'm going to plug in x and y. That's the data. That's the attributes, and that will give me the weights. That will give me the label. Right, so as of right now, your model is trained. It all already been fitted. Now we're gonna predict with it. So we're gonna create another array. We're gonna go to predict. and we wrote the predict method. We're just going to predict. They're called model.predict. And this time I'm not giving it the labels. I'm only giving it the attributes because I wanted to predict based on these, depending on this function that just outputted this. So I'm going to say model.predict, and to show you guys. Okay, so I'm just going to write another line. It might, if you haven't used NumPy, it might seem crazy, but all I'm doing is I'm taking. So I have all the predicted labels, and I'm going to check it with the actual labels. I'm going to see. So at this point, when I say model to predict, I'm only using the function. I'm not using anything. My model doesn't know anything about the data set. It just knows the function, and it knows it's going to get some values, right? So, and then on those values, it will give me the labels, and then I'm going to check with the actual labels. I'm going to see how many did I get right. Right? After learning the function, when I apply that function, how many labels do I actually get right? So that's all I'm doing with this, the NumPy line. It might seem crazy if you haven't seen NumPy before, but don't worry. That's all I'm doing. I'm just checking how many I got right. So is everybody here? Pretty good? Okay. So I run this cell. Did everybody get that? So was everybody able to get that? I'm going to explain that in a minute. Okay, so our accuracy is 90%. What that means is like we had 100 data points, we trained the model on it, and when we gave those data points back to the model, it was able to get 90 of them right. It learned the labels for the 90 of those data points without knowing what the label was. So this is an accuracy. So accuracy usually would be less than 90%. Like I said, like next quarter we'll touch up on these topics, but it's usually like it's never perfect. And if it is perfect, then your model is doing something wrong. And this is a good accuracy of 90%. So our model was able to, so when we plugged back our observations onto the model, it was able to predict 90% of them correctly. Now I can make this accuracy go up a little bit before it starts going down again, and the way to do that, I'm just going to increase the epochs over here. We have 30 epochs. If I train for 50 epochs, right, our accuracy should go up. Because right now 30 epochs has learned some, it still has room to learn. It can go again and ask the points again where they will classify and move the line up and down again, till a certain extent. So I'm going to show that to you. So I'm just going to go up and change 30 to 50 where you are calling model.fit. And just run it again, it'll give you even longer output. The weights will be changed. And when you come down here and you run the prediction again, you get 94. It got 4 more points because I trained it 20 more times. Right? Cool, right? Now I'm sure you must be thinking, why don't I set it to 1,000? Why don't I set it to 100? Because that's the thing. It's after a while, there's no more room to learn. After a while, it's just starting learning like the intricacies of the data we don't want. You're going to stop generalizing. So if I say, let's move it up to 100 then. And it's working for us right now, right? And then I'm going to come back down. And it went down again at 93. So this is a sweet spot. Like you can't just keep increasing epochs and like, okay, I'm going to do it a million times, infinity times, I'm going to go everything in the universe. Cool. But that's not how it works. After a while, it'll start picking up it'll start giving too much weight to like data points that are too far away. Because it's already learned everything for the general pattern, and after that, it's just going to start picking up like the ones that are really far away. And you don't want that. So accuracy will go down. Sorry. And the way you usually do that is you just train it for you. You can't predict it and see where the accuracy goes down. And whenever it goes down, like you got the epoch for that. So right now, let's say 30 worked for us pretty well. So we're just gonna 50 worked for us. So I'm just gonna go in. This is gonna be my optimal epochs to train it on. And I learned it by just trial and error. There's no really scientific formula for that. This is trial and error. Like there's a lot of things in machine learning, these parameters that will be trial and error. Alright, so this is all the code I have for now. And so before I go forward, does anybody have any questions or any concepts? So,
I'm behind. Is there like someplace where I can see this code?
yeah, we will put this code up. We will put this code up on our GitHub. We'll put this code up.
All
And I
right.
also I mean, I haven't annotated it because like we were writing all this by myself, like right in here, so I couldn't put annotations in. But when we put the code up, I'm gonna put like comments on it so you can see where it is. Don't worry about it. I didn't want to waste time like putting in comments right now. So basically the point of that was to like just show you what machine learning is. You know, like we have a lot of people, a lot of students, and rightly so, like it's confusing, and you know, I just wanted to, it's not Skynet, it's not magic. Machine learning is a function. It's math or statistics. All it does, it learns from the data and updates the weights in the function. That's in a very crude way, but that's all machine learning is. And usually you will not be expected to write all this code. So this is a really, really simple model. First of all, it only works for 2 classes right now. You might have 5 or 6 classes. What if you're also trying to predict cats, dogs, and honeybees, or you know other things? But this model only works for 2 classes. And the reason for that, it gets really complicated to write. That's why usually you won't be expected to write this code. You're going to be using libraries like scikit-learn and TensorFlow. We already have all these methods. We just call them on the data. So the point was that just like kind of introduce you slowly and just kind of like demystify machine learning, right? So, but you will not be expected to write all this code. You're usually going to be working with usually like libraries that exist like scikit-learn. If you go work for someone in data science, they'll have their own libraries. And there's a lot of concepts that go into it, and obviously I haven't been able to touch up on it in 1 hour, and that's why next quarter we have 8 weeks of just data science stuff. We're going to start off by doing like stuff like just we're going to start manipulating data sets, and we're going to move on to machine learning, and we're going to go, and like I said, all the we're going to go through a lot of these algorithms, kind of touch up on it, and we won't need to like write all of these. Like we're going to use libraries for all this. Okay. Any more questions? Right. Well, that's all I had. Do you have anything else? No? I hope I didn't put you guys to sleep. I know I went a little fast. You know, like it's usually like it's an hour, and it's usually kind of hard. But we were putting in codes. If you have any questions, you can come up to me. And other than that, Merry Christmas, y'all.